Hello everyone. In this video, we're going to learn how to find the arc length of a parametric curve. We learned how to do this when our curve is the graph of a function, and it turns out a similar formula will work in this case as well. If we have parametric equations x equals f of t and y equals g of t, where t goes from alpha to beta, then the length of the curve is given by the integral from alpha to beta of the square root of f prime of t squared plus g prime of t squared. So let's try to apply this to the example x equals e to the t cosine t and y equals e to the t sine t. We plug these right into the formula for arc length, finding the derivatives to be e to the t cosine t minus e to the t sine t and e to the t sine t plus e to the t cosine t. Once we square these terms out, we find that a couple terms cancel. Moreover, we can pair up the e to the 2t cosine squared of t's and e to the 2c sine squared of t's to get e to the 2t's. Therefore, the integrand simplifies to the square root of 2e to the 2t, which is equal to the square root of 2 times e to the t. Taking the integral and plugging in our bounds, we find that the arc length is equal to the square root of 2 times e to the 2 pi minus 1. Let's go ahead and do one more example. Say we have parametric equations x equals cosine of 2t and y equals sine of 2t, where t goes from 0 to 2 pi. Recall, when we first started learning about parametric equations, we found that this is the parametrization of the unit circle, which has circumference 2 pi r, which is equal to 2 pi. So we would imagine that the length of this curve is given by 2 pi. And let's see if our formula verifies that. We plug in the derivatives of these equations into the arc length formula, and once we square, we get 4 sine squared of 2t plus 4 cosine squared of 2t. Again, we use the Pythagorean identity to simplify this expression to the square root of 4, which is just the integral of 2 from 0 to 2 pi. Integrating and plugging in our bounds, we get that the length of the curve is 4 pi. But wait, I thought we were supposed to get out 2 pi. What happened? It turns out nothing's actually wrong here. All that's happening is that our parametrization goes around the circle twice, which is being accounted for in our arc length formula. And that's why we're getting twice the answer that we thought we would. All right, everyone. That's all I have for you this time, and have a great rest of your day.